Hello everyone, welcome to our Accelerating Flexibility Market session at ENIC 2020. I would like to compliment you on your selection of sessions today. I'm Carolina Tortora and I head Digital Transformation and Innovation Strategy at National Grid ESO. So as you can imagine, flexibility markets is a subject about which I'm very passionate. Today, we will hear from Scottish Southern Electricity Networks, SP Energy Networks, and my very own National Grid ESO on our innovation projects in this area, before going into our speed panel, where I will be discussing the next step to truly accelerate flexibility markets with my network operator colleagues and, of course, external experts. We would like to remind you in the audience that you may, in fact, ask questions to our speakers by using the text chat function in the bar to the right of your screens. Our speakers will be able to respond to you live throughout their presentations. Enjoy!
Welcome to 2020's version of a presentation. My name is Brian Wan, a project manager within SSEN's Future Networks team. Today we're going to give you an update on the Transition project, which is led by SSEN and funded via Ofgem's Network Innovation Competition. Transition will inform the design requirements of a flexibility market, and it will test and validate those requirements through trials in Oxfordshire. It is a 5-year project. The first phase of the project focused on the design requirements. The next 3 years we move into a deployment and trial phase where we'll deploy IT systems, network monitoring, for example, to enable the trialling of flexibility. And now is a really opportune moment for us to give you an update on our flexibility market design.
So Transition has done a lot of work in order to evolve flexibility market design. It's looking at effectively tailoring markets more to customers' needs and the DNO's needs based upon what those markets look like, and drawing upon a multidisciplinary approach in order to make sure that our markets reflect best practice. We're also designing our markets so that they can draw upon new IT tools that will be available to us on the Transition project. For example, the Neutral Market Facilitator, which will enable and make easier trades in shorter time horizons, such as week ahead and day ahead, as well as peer-to-peer type trading. We draw upon expertise as well from markets outside of the electricity industry. Financial markets in particular are a really good example of markets whereby the risk-reward trade-offs offered to customers are set up to be attractive to different customer types in different fields. We're drawing upon other DNO projects as well, NIC, NOA projects in the past, to make sure the direction in which our market design is going in is of course moving the industry forwards in a way that is consistent across the DNOs. And then we're using insights from, in particular, behavioral economics to make sure that the economic principles that we're introducing in the transition markets are simple and translatable and don't pose barriers to entry for people who want to enter flexibility markets. And of course, all of these things are being bounced off stakeholders throughout to get stakeholder feedback to constantly iterate and improve our market design. So what I'm going to do over the next 15 to 20 minutes is basically take you through 3 main steps which have fed into Transition's market design. The first of those is tailoring markets to both the types of competition and the levels of liquidity we have in a market to ensure that those markets are run in the most cost-effective manner. Secondly, it's introducing new types of ways of considering the risks that customers might have to face if they participate in a market. For example, within building their business models to ensure that we can give them certainty so that they can participate in the market where in the past they might have struggled to. And then finally, a set of market stimuli packages which are set up, as the name suggests, to effectively stimulate new people entering the market, to allow them to enable their flexibility and to offer simplicity of approach to people who at the moment the market seems too complicated. So focusing on our tailored market approach, we're using 3 indexes which help us tailor a market. Those indexes are a market competition index, a market liquidity index, and a market reliability index. And for each of these indexes, we will assess the market and we will then tailor the procurement approaches, the pricing approaches that we take in order to settle that market. Okay, so for example, what we've got on the slide behind me is the Market Competition Index. The Market Competition Index will assess, as the name suggests, the amount of competition within the market. Now, this can vary quite significantly from highly competitive markets, what you can see at the very top of the slide, right down to purely monopolistic markets where you've got just one person operating the market. And in between that, you have varying degrees of oligopoly, imperfect competition, where you maybe have monopolies interacting with degrees of competition. And as a result, the way in which you might run those markets might differ. So for example, in the more monopolistic markets, what you really want to do there is drive competition into the market. So you want mechanisms which are simple for people so that they are encouraged to enter that market. Things like fixed prices, simple auctions, and price ceilings can be used to attract people to those markets. As you've got more competitive markets, however, you've got more of a market setup that you want to start to see for running flexibility. It will probably be more robust because if one of those customers drops out, you've got a degree of competition, and you'll see price being driven down, meaning more cost-effective markets for wider customer bases. And as a result, when you run these sort of markets, you want price to be driven more by the market itself through things like more dynamic auctions, maybe even clock auctions, which allow people in real time to adjust their price and drive down costs within the market. The second of our tailored market indexes is our Market Liquidity Index. The Market Liquidity Index effectively assesses whether there is enough supply, or at least signaled supply of flexibility within an area to meet the DNO's potential demands for flexibility. So for example, the DNO might be requesting a megawatt of demand in a given area. That's never going to happen if you've got a market where there's only 600 kilowatts of flexibility who have signaled availability to you. Now, that doesn't necessarily, for the long term, mean that you shouldn't run a market in this area. In the long term, what you might see is that more flexibility could be likely to come about in this market. And as a result, through just a bit of market stimulation, what you might have is a functioning flexibility market. As markets mature more and more within the flexibility field, and as we move throughout RIIO-2, we expect to see more and more levels of liquidity within our flexibility markets. And eventually, supply of flexibility will, in general, across our markets, exceed the demand for flexibility by increasing extents. Now, as your supply and your demand for flexibility change, you might like to change the market structure that you offer. So once again, with, let's say, some current markets whereby you've not got that much liquidity, what you might like to do is encourage people to enter the market. And as a result, you want to offer very simple markets, price taker markets, for instance, with the opportunity of long run revenue streams, long run contracts, for instance, whereby they can see that they will make money in the market into the future and as a result can justify investment. As markets get more and more liquid, what you might look at doing is actually moving those markets down towards more short-term markets and short-term contracts. The benefits these bring for customers is that the customers are more able to service stack because they can decide which market they want to participate in on a week-by-week basis, so they can act more dynamically. For the DNO, this means that we can respond to network needs in more real time, and as a result, run the market in a more efficient manner. The final of our market assessment indexes is our Market Reliability Index. Now, the Market Reliability Index will assess not just reliability, but also robustness of the market. And what exactly do I mean by this? Well, reliability of the market is if I'm procuring a megawatt, how likely from the assets that I've procured am I actually to get a megawatt? If those assets have reasonably wide confidence intervals around them, and as a result, if they have wide variance in what they might give me on a week-by-week basis, maybe my confidence is less in that market, and as a result, my reliability is lower, so I might need to over-procure by more. By robustness, what I mean is the level of robustness to kind of an external shock or a single event that the market might be able to take. So for example, a competitive market with 100 different customers all providing you small amounts of flexibility might be highly robust, because if one of those customers goes down, you've still got 99 customers providing you flexibility. You might have lost a little bit of load, but you can probably still manage the peak on the network. A monopolized market, however, with just one customer providing you all the flexibility that's needed, if that customer drops off or goes down, you suddenly lose all of your flexibility in the market. And as a result, you've got a very fragile market, a market which is not very robust at all. And we should assess our markets based upon this. We should look to stimulate more reliable and more robust markets, because all of that will help us run the network more effectively. So what you can see on the slide behind me is that we will have an asset reliability index and a market reliability index. The asset reliability index basically tells you for different types of asset how likely they are to deliver the level of demand response you've contracted with them. So some assets, for instance, maybe a battery, might be very reliable. When you call upon them each week for 100 kilowatts, they will give you 100 kilowatts. And as a result, they are a very good asset to have in your market, because you know whether it be summer or winter or day or night, what level of flexibility you get from them. Other assets, however, might be more variable because they're determined by behavior or weather or whatever it might be, and as a result, they've got a wider variance to them. Now, this doesn't mean that we can't use them in the market, but it means that we need to start to understand what those confounding variables, those things that affect the reliability of this asset are, and we need to understand if this asset is unreliable, how do we potentially weight that against a reliable asset, and how therefore do we need to over procure across the market as a whole. So what you can see on the left-hand side of this diagram is that different types of asset, purely example again here, none of this is actual data, might have different normal distribution curves to them, indicating different variances to the assets. Bringing all of that together, what you might see is that in the market, you have a certain normal distribution curve to the market as a whole. You might need to procure X amount of kilowatts to meet the level of flexibility you need in that market, but because you want 95% certainty that you'll get X kilowatts, actually this will recommend that you over procure by X plus Y kilowatts instead. So you can see how hopefully these different asset reliability indexes feed into the market reliability index to indicate robustness, reliability, and the need to over procure potentially. Where this gets even more interesting, and where we add another layer on top of this, is when you start allowing assets to service stack, how does that then start to affect their reliability index? If we can start to assess this, we can start to see that actually, whilst in our example given earlier, a battery might be very reliable, a battery that's participating in 10 different markets might not be that reliable to us. And as a result, we need to again reflect that in our market reliability index, and see how that might change how we should pay this asset, or how we should weight it in auctions, and therefore how much we should over procure in auctions as well, because that asset might have become less reliable to us in terms of its ability to respond. Bringing all of this together, what we have is a market sort of flow for different types of asset. So an asset can register itself, they can see that there might be several markets they can participate in, they register their asset and they pre-qualify their asset with us, which will include some sort of reliability assessment. What we then do is we will then assess the market based upon competition and liquidity once we've seen everyone who's qualified for the market, and we will decide whether markets are not competitive and not liquid, competitive and not liquid, not competitive and liquid, or competitive and liquid. And as a result, we will vary the duration of the contracts or the procurements that people can sign on to, whether those be long run or short run. And we will look to offer different price mechanisms or different procurement mechanisms, varying from fixed price to sealed bid procurement to clock auctions, based upon those market durations and those market competition liquidity indexes. Once those auctions have been run, customers will sign on to the flexibility services agreement contract, and they will be available for us to procure flexibility off of as and when the network needs. So this market approach has been received very well by the vast amount of people that we've discussed. However, different stakeholders obviously have different needs, and some of the stakeholders who we pose this to came back with comments such as the thoughts of how I participate in auctions and long run or short run markets confuses me. How do I make decisions around that? I don't understand how I participate in these markets. It's overcomplicated for a small asset like myself. Prices as well. With prices settled through the market, customers say that they struggle to get any sort of indication of the revenue they can earn because DNO markets can be so geographically specific. They understand that price can maybe swing significantly, and because they're quite immature as well, there's not huge amounts of price point data out there to inform decisions. And finally, in terms of risk, people said there's too much risk involved from prices varying from area to area, and as a result, they can't justify an investment to enable their asset to participate in our markets. So what have we done to address this? So what we've done is we've effectively introduced an alternative route to the market for these customers who are maybe more risk averse or maybe want simplicity. And the way to think about this alternative route to market is if your blue route to market up top there is settled by competition and liquidity, it's settled by the market itself, it's variable, okay? Much like a variable mortgage that you might get from the bank when you're buying a house, okay? The interest rate on that will vary based upon things that are going on in the wider economy that are maybe outside of your control. The green route here can be looked at almost as like a fixed rate mortgage. It can be looked at under the same methodology. What it basically does is it will take risk out of the market for you as a customer. It will transfer that risk to, in this case, the DNO in the mortgage example, the bank. And as a result, it will offer you a means to market whereby you can be sure of exactly what you will get paid on a event by event basis. So it's a non-competitive route to market that almost offers almost like a price floor to customers for their participation in the market. So if they don't want to bother with any of the complexity of the auctions, of understanding what type of market they'll be a participant in, they can simply take this fixed rate route to market. They can get a certainty of payment over a given duration of contract, and they can use that to justify making an investment in their asset to enable it for flexibility. What we're effectively doing in this instance is transferring the risk from the asset owner to the DNO, who are potentially more informed around that market, certainly as things sit at the moment. So following on from the introduction of our fixed rate route to market, we went back to our stakeholders, we presented back our solution, and again, a wider subset of stakeholders commented back on our routes to market, largely with positive feedback. However, again, we have a certain subset of customers who maybe still struggle to see how they'd access the markets. And these are the sorts of customers who maybe are less engaged, maybe they struggle to understand what the DNO is talking about when we mention a certain secure or dynamic or sustain or restore service. Maybe they're types of customer who the existing contract, the FSA, the Flexibility Services Agreement that is, aren't suited to. Or maybe even they can build a justifiable business case, but their organisation isn't willing to take on the risk. It's too new to them, and it's not a big enough priority for their financial teams to get engaged. How can we help these customers? How can we stimulate these customers with access to the market? And what we did here was to design 3 packages: a flat rate package, a flat rate plus capex support package, and a capex support and then competitive route to market package for the different customer types that we still saw struggling to enter the market. So the simplest of these packages is the flat rate package. Flat rate package might be targeted more at kind of domestic customers, even maybe with large dispatchable load like an EV. And what it does is it says very simply, we will pay you a certain amount per kilowatt, and what you have to provide us is a certain amount of events in return. Okay, and there's minimal qualification to that market. All you need to do is show to us that you do have the level of kilowatts available from your flexible asset that you're telling us. So for example, we might say we'll pay you £2 per kilowatt. You've got a 30 kilowatt EV battery that can run for an hour consistently. As a result, by the end of this contract, we'll pay you £60 if you can deliver 10 1-hour events to us within the parameters that we need. The parameters will be quite simple. It'll be things like 4 to 8 o'clock, weekday evenings, potentially during the winter. Okay. The second package here is a flat rate and capex support package. Similar principle to the first package, maybe more for customers who need to enable the flexibility they've got. So they might need to put some sort of monitoring on it so that we can see that they are actually delivering flexibility, or they might need to add some sort of dispatch or automation technologies to the asset. And as a result, we offer them an upfront payment to support that enabling, and we then offer them again a certain payment rate per kilowatt in return for them to deliver a higher amount of events to us. Again, minimal qualification type criteria required here, more suited maybe to again some EVs, maybe SMEs as well. And then the final package that you've got is the CapEx and competitive package. This is more suited to small commercials, the types of organisation that would be suited to participate in the competitive or the fixed rate route to market. They'd be suited to the flexibility services agreement. However, at the moment, they see there's a significant cost in order to enable their asset that they can't get past their internal, let's say, finance departments. So what the point of this is it's to offer some sort of CapEx support in order to enable that asset. Once that asset's enabled and once it's received that CapEx support, the asset will have to sign on to a market for a given duration, let's say 2 years. By participating in a 2-year market, the asset will slowly repay the amount that it has borrowed from the DNO in order to enable its asset, and going into the future, they will have a flexible asset which is ready to participate in more flexibility markets. You can see this final route to market added in red at the top of our diagram here, indicating those 3 market stimuli packages, a need of an additional or a different sort of legal set of terms and conditions to sign customers onto those packages, and the different routes that they then take from then on to make sure that they are utilised. Those flat rate and flat rate CapEx markets, because they're paid for separately, or upfront, effectively become zero marginal cost assets to run within the market that can be used to almost block stack different services together at a more granular way than potentially the main market. Again, providing the DNO more flexibility in the way that it utilises the market, stimulating more competition and more liquidity in the market, which in the long term should all ultimately drive down prices to customers, enable more people to participate in flexibility, and ensure that the system continues to operate in a reliable and robust manner. Thank you all very much for listening. I look forward to your questions on the panel, and you can see there that there is a get in touch link on the transition website where you can contact us for more details.
Our energy landscape is changing rapidly. Demand on the distribution network is increasing, particularly as we become more reliant on electricity for transport and heating. A rising number of customers are also seeking to connect distributed generation, such as photovoltaics or wind turbines, to our network. Traditionally, we respond to increasing demands like these by reinforcing the network to accommodate them, but this takes time and has significant costs. We therefore need to find smarter, more agile and cost-effective ways to manage our network, as it is now being asked to do things it was never built for. We can go a long way to solving these challenges by working directly with our customers to make our network more flexible. This means rewarding our customers for playing a role in helping to balance local generation and demand. Through trials in St Andrews and East Fife, SP Energy Networks Fusion project seeks to demonstrate how the introduction of a local demand-side flexibility market can help the distribution system operator to better manage their network. The Fusion project will trial the creation of an online interactive platform that allows DSOs to signpost local network requirements to the market and then purchase customer flexibility to alleviate localized network congestion. This approach of utilizing flexibility represents a new kind of interaction with our customer. The online platform will advertise network flexibility requirements. Aggregators, i.e. those who represent smaller flexibility providers, and larger commercial operators, agricultural business or prosumers, can then respond to these needs with a bid to sell their available capacity. Examples of ways in which the successful bidders could provide flexibility include temporarily reducing their grid electricity consumption to lessen their demand on the network, activating local generation assets to provide additional local supply, or switching to consuming energy from an on-site source of storage or generation, and therefore freeing up capacity on the network. In return for voluntarily operating their assets in this flexible way, the bidders could generate an income whilst providing a critical service to our network. Trading will adhere to the protocols set out in the Universal Smart Energy Framework, an internationally recognised standard for trading flexibility. By unlocking the value of our customers' flexibility, Project Fusion seeks to defer or avoid the costs of these reinforcements. Demonstrating how local flexibility markets can provide a fast and cost-effective tool will help the DSO to actively manage its network and deliver a better future, quicker for our customers. Want more information? Get in touch via fusion@spenergynetworks.com or visit our website.
Project Fusion is a £5.6 million innovation project, and we are tasked with delivering a local flexibility market in East Fife. Flexibility, at least from a Fusion perspective, represents a service which our customers can offer to us in response to a signal from us whereby we say we need something to help us manage our network. And so that's what flexibility is. It's a service. And a flexibility market, as the name suggests, is just a way of describing how we commoditize that service in a competitive market environment. And so the key ingredients to a flexibility market there are 3 Ps really. There are participants, a platform, and a process. So as with any market, you need participants, you need supply and demand. In the case of Fusion, the demand or the buyer is SPEN, is the DSO. So we will be looking to our customers to provide this service to us, and we will be offering to remunerate them for that. So we're the demand. The supply comes from the customers who are able to offer that flexibility. So that's the participants. Second, I said we need a platform. So that's literally it's a web hosted or cloud hosted platform, IT platform through which we as the DSO can interact with the flexibility providers, who are normally aggregators who represent the customer. And that platform allows the DSO to advertise our need in terms of what flexibility we need. The flex provider can then respond to that need with costs and availability. And in that same platform, we're able to actually contract with a suitable flex provider and issue dispatch notices to dispatch it. And ultimately, we can settle and remunerate them for that service. We look to flexibility markets really as a way to help us to manage our constrained distribution networks. So if we have constraint on a network, we might turn to our customers and ask them, can you help us can you modify your consumption patterns, your generation patterns in a way which can help us to manage that constraint on our network? Say we have customers who want to connect and we're saying we can't physically connect you with a firm connection until we can reinforce the network. That reinforcement takes time, and flexibility helps us to manage that existing constraint so that we can accelerate connections of customers instead of making them wait for connections. And that could mean that we can accelerate the connections of renewable energies, which could indirectly reduce CO2. In the case of Fusion, we are delivering this local flex market in an area of existing network constraint. And so we're looking to flexibility as a means to manage that constraint on the local distribution network. And the benefits that delivers to local customers there were 3 main benefits. First of all, it means that we might be able to accelerate the connection of local customers in a constrained area without them having to wait for reinforcement. Secondly, it might mean that we can defer the need for that reinforcement, which can save cost both to us and to our customers. And thirdly, customers who are able to participate in this flex market have the opportunity to generate an income through the flex market as well. So it's really financial savings and speeding up connections. I suppose the next key milestone is we will start the live trials in June next year. And as with all projects, as with all sort of ambitious trials, you can't just start trialing from day one. You need to you need to lay the foundations first. And I suppose the previous 2 years, I know the previous 2 years have been basically laying the foundation so we can facilitate this live trial. I mentioned earlier that a local flex market comprises 3 main ingredients. You've got the participants, the platform, and the processes, and we've been basically developing all of those to a condition whereby they're ready to bring together into a coherent organism to trial in June next year. We anticipated that it might have quite an impact. Certainly, one of those three ingredients that we talk about are the participants. And East Fife isn't a particularly densely populated area, so we don't have a lot of assets in the area. So we're already fairly limited physically by we don't have a huge amount of flexibility resource there. And what little resource we do have, we need to go and meet with those customers. We need to understand their assets, their technical viability to participate, their commercial and political appetite to participate. And all of this takes time and effort and relationship building, and therefore any sort of imposition, any sort of impediment to meeting with people is going to obviously cause a barrier. But I'm grateful to say that we've not encountered the types of delays or barriers that we thought we would. I think thanks to Teams, we've managed to engage as well as we could have done anyway. Whilst it is encouraging that we're getting greater and greater volumes of flexibility traded, with greater volume comes greater complexity in terms of the interactions with the market. We require increasingly sophisticated processes to manage those interactions, and it presents a challenge. How do we do that? And that's really the gap that Fusion seeks to address. So we are implementing a framework which sets out the processes for managing the interactions with the different participants in this marketplace. And that framework is called the Universal Smart Energy Framework. The acronym is USEF. And so one of the key innovations that sit behind Fusion is the trialing of this framework. It was developed in the Netherlands. It's as I say, it's been developed specifically for quite sophisticated market interactions. It's been employed there for a number of years. It's mature, but Fusion represents the first deployment of USEF in GB. And so we hope that by implementing it here, we can put it through its paces and extract useful learnings which are relevant to not only us but to the wider industry with the Open Network project. And that's what we'll be doing in June. So in view of what we see as an expanding and growing market, we anticipate a commensurate growth in terms of the complexity required to manage that growing market. And so we're trying to pioneer, or at least we're trying to trial one potential way of managing that, one potential framework for managing those complex interactions, and take the best learnings from that so that we can inform the industry. Certainly, once we commence live trials in June, we can start generating real empirical data. And once we get that, we can start analyzing it and sharing valuable interim learnings with our colleagues and with industry colleagues as well. So certainly there's going to be a marked increase in value from June onwards. But that's not to say we haven't delivered value already. A lot of the work we've been doing has really been just trying to get all of the pieces of the puzzle in place so that we can deploy that flexibility trial. But as part of that preparatory work, we've been working closely with the Open Networks project, and we work with them via the TEF consortium. So it's a collection of three innovation projects from SSEN, WPD, and SPEN. The acronym is TEF. It stands for Transition, Fs, and Fusion. And we are basically three innovation projects who share some degree of synergy in the sense that we're all exploring this flexibility field. But we all approach it from slightly different ways and offer unique and complementary learnings. And so we meet monthly to share our evolving and emerging plans, to make sure that we are all aligned, both in terms of to ensure that we're not duplicating one another and that we're offering, as I say, complementary learnings, but also that those learnings are directed very much towards the needs of the Open Network project. So we're very carefully aligned. And that in itself has meant that we've been able to interact quite closely with the Open Networks project, and we've been able to, as we start to get the pieces of the puzzle ready for our trial implementation, we've been asking similar questions to the Open Networks project and our TEF partners, and so we've been able to contribute towards the evolution of key documents. For example, the Flexibility Services Agreement. That's a contract which DSOs will sign with flex providers. And the ambition is to develop a standardized contract. And so we've been collaborating with other DSOs to inform and review and approve that standard contract. The trials are really split into two phases. Phase 2 will be much more ambitious and sophisticated in the sense that we will be applying real flexibility to real network needs to save real money. Phase 1 is a bit more of a proof of concept. We're still dispatching real flexibility, and it's going to really manifest itself on the network. There'll be real customers involved, but we are not doing so to directly address real network issues. They're going to be simulated issues, and so once we've contracted availability from June till December, we will actually simulate events and call upon flexibility from those providers, and that will manifest itself in real delivery of changes to their operating patterns. When I was first given Fusion as a project to manage, it's quite daunting. I think with any innovation project, you can see the outline of where you want to get to. Everyone's clear on, or more or less clear on, what you want to achieve, but it's what's unclear is perhaps how you get there. And I think as you progress along, as we've progressed along with Fusion, now that we've got this trial in sight, we've got the date, we've got the 3 ingredients as we talked about, we can start seeing this picture emerging more and more clearly. And I think once we actually start interacting through the platform and we can generate those initial learnings, I think that will give us really valuable insights to help us to, the plan is to start small and then build our ambition as we go along. And so as soon as we can start to generate those initial learnings, that can give us the confidence as to where to invest our resources and really add value. So I think the next 12 months are going to be very exciting, and I'm confident that we're going to deliver real value to the industry. Yeah.
Is Biljana Stojkovska, and I'm working in National Grid Electricity System Operator. I am the project lead for Power Potential project, which is trialing reactive power service from distributed energy resources. Power Potential is a world first project in trialing dynamic voltage control from small generators for system operator, and is also a project which for the first time is establishing a new reactive power market from small generators. More than ever, voltage control service is very important for system operator. In this project, we are proudly applying groundbreaking engineering and economic principles with major aim to support future innovation in reactive power markets and ancillary services. Is focusing on the trial region of southwest part of the transmission system, where transmission system is interfacing with distribution system. Grid supply points of the interest are Bolney, Ninfield, Sellinge and Canterbury North, and all small generators connected in those areas are eligible to participate in the trials. Project, which started in 2017, has 2 major deliverables. First deliverable is technical solution, which means build and test a distributed energy resource management system to enable active and reactive power from small generators. And the second deliverable is the commercial solution, which means creating a regional reactive power market to provide services to electricity system operator while keeping the distribution network within operational and planning limits. The trials consist of 2 waves. We are currently in wave 1, where we are trialing the proof of concept for the technical trials, which means that we are doing technical service validation without commercial assessment. technical trials will finish on 10th of December. Upon completion of optional technical trials, we will start commercial or market trials, in which we will do the price discovery trials. They will start on 14th of December and continue in 2021, finishing on 28th of March next year. It is very important that objective of this wave is to establish the commercial viability of the reactive power market with commercial assessment for offers from reactive power services from small generators. Technical solution is end-to-end service from National Grid ESO via Distributed Energy Resource Management System, which is hosted and located in UK Power networks, to the end users, which are small generators. On the left-hand side, National Grid ESO is entering the request for the service into Platform for Ancillary Services. Request for the service goes into DERMS. DERMS is interfacing with UKPN Control Center and Distributed Energy Resource Substation and instructing the request for reactive and active power service. Here I would like to present some practical results so far. On this particular slide, it's a proof and demonstration that the small generators can provide dynamic voltage control. On the left-hand side, you have a reactive power. On the right-hand side, you have a voltage. It is clear for the graph that the voltage, which is actually the voltage set point sent by DERMS, is following by reactive power, the green line, which is produced by the small generator. So you can see that the small generator is closely following the need for voltage on transmission system with producing a reactive power, which is in a green line. These results are demonstrating capability of generators to provide leading and lagging reactive power. Results are results on this slide, where we can follow how the small generators are reacting on a change of the voltage at the grid supply point. At the first graph, on the top, you can see that the voltage is lower than system voltage and it's higher than deadband. That means that the small generators are required to provide leading capability or absorb the reactive power. In the period after 1700, system voltage is slightly lower than the requested deadband from the system operator. You can see on the graph below, in green, majority of the generators are in sort of lagging mode and providing a required reactive power to support the voltage on transmission system. In the time when voltage is within the deadband, the generators are not producing any reactive power. As I said, we are in the moment doing the trials. There's a lot of work to be done to understand what data are telling us, and we are looking forward to the next stage of completing optional trials and start active and reactive power market trials.
I'm Dr. Rita Shaw from UK Power Networks, and in Power Potential we deliver the majority of the system's commissioning and trial support to enable the reactive power services from distributed energy resources to transmission. Delivering an automated system for secure reactive power services requires a complex integration of systems. At last year's LCNI, I talked through the software and integration challenges we had overcome in 2019. 20 systems across a variety of protocols, ICCP, DMP3, web services, Azure hosting of the web interface. This year's story is the next step, quite different, delivery and into live trials. With a range of suppliers, including Ziv Automation, in 2020 we completed our build and test, delivered successive upgrades to the system, and been progressing through live technical trials. And that's how we've got there, is what I'll be taking through in the last part of this presentation. The first two live stages were commissioning and then mandatory trials for each individual DER. Taking the site commissioning first, we had deployed changes to our power on control system to give extra visibility to our control engineers, and upgraded the remote terminal units at each DER site with new logic and new visibility, so that we would be able to do the overall integration checks all the way from DERMS through to the DER as part of commissioning. We commissioned the first customer just before lockdown in March, and after that we then to more of a remote delivery approach for the next stage, which was mandatory trials. Within mandatory trials, we dispatch each DER based on a simulated GSP requirement, with DERMS calculating voltage set points to send to the DER so that they deliver an appropriate reactive power response. And we've now been through mandatory trials for solar, battery and wind customers, and the trial participants have been absolutely key to this. They see in the long term that although this is a trial and a proof of concept, there's potentially value to them of being able to deliver a valuable voltage control service to transmission. So we started the Wave 1 trial stage once we had 3 DER through their commissioning and mandatory trials. And since then, we've been working to bring on the other 2 DER project. But the parallel activity that we've been delivering this year has been the series of build and test and deployment activities associated with the enhanced functionality that we needed for the Wave 1 trials. So this has meant the improvements to the platform for ancillary services, the web services link between PAS and DERMS, the upgrades to DERMS and the DERMS user interface, and the changes to allow DERMS to interact with our settlement solution. So having delivered the individual trials, we're now in our Wave 1 technicals trial stage for 8 weeks, and importantly those are end-to-end, continuous and collective trials, simultaneous DER response, and being supported by the National Grid and UKPN control room functions and the wider support systems within National Grid and UK Power Networks. And the learning from those is really important to put us on a good footing for that next stage. This has been a very fruitful year, both in terms of documentation and experience derived from the stage we've now reached in the project. In terms of documentation, we've updated our DER interface schedule and test specification. We've developed and applied a commissioning test procedure and developed a remote approach for delivering the mandatory trials in collaboration between National Grid, UK Power Networks and most importantly the DER. And this project is nothing without the customers as well as the technical site aspects. DERs are also needing to provide information on a daily basis through the DERMS web interface to indicate when they're available from the service. So we've developed a series of web interface guides to be able to guide them through those stages. So what we've delivered by the end of this year is many hours, weeks of experience across multiple DER, across UK Power Networks and National Grid. Importantly, we have the acceptance of our control rooms for this service. We've settled the trial payments with DER, and crucially we've used our learning from these initial technical trials to make some adjustments to the system, particularly around limit levels, limit frequency of sending limits, tolerable data traffic to be able to make adjustments to put us in a good position for the next stage of trials. So at this point, thank you very much for your interest and time, and Biljana and I would love to hear your questions. Thank you.
Hello everyone, it's great to be here at the Energy Networks Innovation Conference 2020. This is Yingyi from National Grid ESO Ancillary Service Development Team. I will talk you through how does closer to real-time procurement impact the market liquidity and procurement cost with our initial findings from the Auction Trial Phase 2 project. Today, I would like to talk about what is the Auction Trial project, how the algorithm works, some key learnings from the project, and our plan for the next steps. I will start with some high-level introduction about this project. In the past few years, the firm frequency response FFR products are only procured through the monthly pay-as-bid tenders, which require suppliers to submit their orders 1 month ahead. But not all participants can accurately forecast their availability over that long time horizons, especially the intermittent generators. So we initialized this 2-year NIA-funded project to trial the procurement of a portion of our frequency response requirements via weekly pay-as-clear auctions. The trial is designed to test the hypothesis that closer to real-time procurement would remove barriers for non-traditional participants. We expect that this would promote competition and increase liquidity in the frequency response market, reduce our overall balancing costs, and deliver value for the end consumers. It supports one of our core forward plan deliverables, the Roll 2, and the lesson learned in this project will also get us prepared to move to day-ahead auctions. Auction Trial Phase 1 began in September 2019. Initially, it was operated by a manual system. Then this in-house system was replaced by an online platform, provided and run by our project partner, Apex Sport. We are now in the Phase 2 of this project, which went live November last year. 2 products are procured through weekly auctions at the moment: the low-frequency static LFS and DLH dynamic low-high. Here's an overview about how the algorithm works. First of all, sell and buy orders are collected from participants. Sell orders are sorted by the price, from the cheapest to the most expensive one. The objective function to determine accepted quantities is to maximize the market welfare under the given constraints, like the multiple period order must be either fully accepted in all IFA periods or rejected in all IFA periods on which it is defined. The last step is to minimize the market price. Here we use overall market welfare to determine the order acceptance, because when the market welfare is maximized, we are approaching the allocative efficiency, and the surplus is evenly split between producers and consumers. At this point, capital is allocated in a way that is most beneficial to all parties involved. One key objective of the trial is to lower barrier for non-traditional participants. Have we achieved that? We issued a survey in May asking market participants how do they feel about the auction trial. One question we asked was, from a scale 1 to 10, how you would like to rate monthly tenders and weekly auctions as your main route to the market. As shown in the pie chart, 38% respondents selected monthly tenders are still their main route to the market because more volume being procured in monthly tender than weekly auction. But if we look at the bar chart on the left, weekly auction was given a higher overall score in this question. Participants who cannot or have barriers to join the monthly tenders gave weekly auctions some extremely high scores. So the conclusion is we indeed lower the barrier for participants. This also reflects in the positive feedback we received from some DSR participants. For example, weekly auctions allow the dynamic nature of some DSR sets, where operational patterns cannot be planned a month in advance. Till end of October this year, 49 auctions have been held successfully. Number of participants increased from 5 to 19, almost 4 times bigger. Technology type includes battery and DSR. As shown in the top graph, our target is to procure 100 megawatts each EFA block. At the beginning of this trial, on average, we only been offered 40 megawatts. The clearing volume is even lower. But now we start saying all EFA blocks are fully cleared. In some EFA period, we were offered nearly double amount as what we planned to buy. Below graph is about the HHI, which is an index to measure the market concentration. If there was only one supplier in the market and it took 100% market share, the HHI would equal 1. Whereas when the HHI close to 0, it indicates perfect competition. As we can see from the graph, DLH market's HHI is approaching 0, which means market shares are evenly split among suppliers. The market liquidity is high. DLH market clearing price has dropped significantly from around £9 per megawatt hour in late February to below £4 in August as a result of the increased market liquidity. And it is a bundle product, which means suppliers need to provide us 1 megawatt low frequency response as well as 1 megawatt high frequency response for that price. On average, DLH auction price is lower than the monthly FFR tender price for an equivalent bundle of that services. The weekly clearing price bounced back in September and October. Due to the strong competition and low price, some participants moved out weekly FFR market in September and into the dynamic containment soft launch in October, which lowered the weekly market liquidity further. We achieved a high market transparency in this project by publishing the full market results instead of only allow each participant saying their own results. Participants speak highly about this. We were given an average score of 8.5 out of a total score of 10 for the communication and transparency of the auction results in the market survey. According to the survey feedback, participants indicated that the weekly auction operational processes worked well for them. It took them less time and efforts to prepare for a single auction compared to a monthly tender. However, because the weekly auctions happen 4 or 5 times a month, 60% participants stated that the overall efforts for the weekly auction is equal or slightly greater than the effort required for the monthly tender. There are some works have been done to improve suppliers' experience with us. Like we have published a simplified Apex Spot user guide. An additional validation has been added on the bid submission to reduce the risk that a stacking sale order being submitted in error. We will continue to explore the possibilities for further operational improvements. There are some important lessons we learned in this trial so far. First of all, when the market liquidity is relatively low, an elastic bid curve could be applied to simulate the effect of additional competition. When designing this curve, parameters like inflection point, number of points on the curve, slope of the curve are all important considerations which need to be set carefully. It is recommended that the marginal prices should be restrictedly greater than 0, Otherwise, it will result in consumer paying less money for a higher cleared volume, which doesn't make commercial sense. Secondly, one of the constraints we used in the algorithm is called merit order rule, which means higher priority is given to basic blocks. If a basic block of volume X is rejected, the algorithm cannot accept more than X of more expensive upper bid orders. It is designed to encourage suppliers using simple bidding strategy to make the market results easier to understand. However, this rule didn't work as we expected. So, it's important to assess all assessment rules altogether, not individually. Sometimes the simpler rule, the better outcome. Lastly, the procurement volume needs to be optimized and reviewed regularly. This is what we are working on at the moment. We had a fixed total procurement volume cap, which is 100 megawatts, since the beginning of the trial, but it has been reviewed and increased recently. How closer to real-time procurement can result in more accurate procurement decisions is a topic we plan to investigate further. Here are some important lessons we learned in this trial so far. First of all, when the market liquidity is relatively low, an elastic bid curve could be applied to simulate the effect of additional competition. Secondly, we noticed the merit order rule, which is designed to encourage suppliers using simple bidding strategy to make the market results easier to understand, didn't work as expected. So it's important to assess all rules altogether, not individually. Sometimes the simpler rule, the better outcome. Lastly, the procurement volume needs to be optimized and reviewed regularly. That is what we are working on at the moment. How closer to real-time procurement can result in more accurate procurement decision is a topic we plan to further investigate. Overall, the project goes on really well. Those positive feedback has been received from participants, the real incentive panel, and Ofgem. The last topic I want to cover today is what we plan to do next. According to the survey feedback we got in May, the top 3 barriers participants had to entry were 20 megawatts unit cap, 100 megawatts total procurement volume cap, and the standardized product design of DLH product, which requires equal amounts of high-frequency and low-frequency response to be offered. The 20 megawatts unit cap has been removed in September, and we have very recently increased the 100 megawatts total volume cap in line with stakeholders' feedback. To further lower the barrier for participants who have asymmetric capabilities, one of the key improvements we will explore next is to trial the separate procurement of low-frequency and high-frequency services with a linking by products function. This will improve the market design by increasing flexibilities for both ESO and market participants. Previously, we only allow suppliers to link their orders by time. For example, they can submit a multiple period order. When the linking by products function gets delivered, participants will have full flexibility to bid in any way suitable for them. They can link their order by time, or by products, or both. We desire to understand how this will change suppliers' bidding behaviors and how this will impact the clearing price and market transparency. That's all for my presentation. Hope you enjoy it. Bye!
Hello, my name is Peter Chandler, and it's a pleasure for me to be presenting to the Energy Networks Innovation Conference today. So I am the lead for the Distributed Restart project, and today I'm going to take you through the latest project findings. So our mission is to investigate the viability of utilising distributed energy resources and delivering black start and testing capability and if we're successful, create a roadmap for integration into business as usual. Distributed Restart is a 3-year partnership between National Grid Electricity System Operator, Scottish Power Energy Networks and TNEI to deliver a bottom-up approach to black start restoration. That is the ability to restart the country's energy supplies following a power outage from the distribution networks all the way up to transmission voltage level. So 3 main objectives for this project. First, to introduce competition into the black start arena and ultimately reduce cost to consumers. Secondly, to reduce the carbon footprint of black start providers through incorporating cleaner energy technologies. And thirdly, to future-proof the country's black start restoration plans by integrating this approach with the traditional top-down approach for black start. This project is really broad and ambitious in scope, as we're looking to marry the solutions to overcome the power system technical challenges, the organisational structures, the operational telecommunications, and the commercial framework in order to deliver a world-first bottom-up approach for restoration. So highly exciting stuff. So what have we done so far? So we've explored a number of different case studies across the Scottish Power Energy Network's licence areas, and we've conducted extensive power system studies on those sort of network studies. We've got some learning around that. We've honed that number of case studies down to a smaller number that we're doing some detailed design work on at the moment, which will then go forward into live trials, which we'll be doing going forward into 2021. So these live trials, we've got different technologies involved. So we've included hydro generation, biomass generation, we've got battery energy storage, wind and solar. So all form part of our case studies, which will filter into our sort of live trials. So what else have we been doing? Well, we've designed the requirements for cyber secure and resilient telecommunications and automation. So we've got some reports coming out with our sort of detailed function requirements coming out in December. We've also designed a commercial framework to take forward into the next phase and refine that with increased stakeholder engagement. And a big piece of work that we've been doing, we've actually designed an organisational structure and control philosophy. So how do we organise ourselves to deliver black start on the day? Who talks to who, and how all that sort of fits together? So we've been working with stakeholders all through all different phases of the project so far, and we'll continue to do so. So the drawing on your right hand side just take you through a few sort of definitions, I suppose. The anchor generator, so this is a case study that we're developing, and the anchor generator is what we're calling the initial sort of black start generator. So the ability to self-start, the ability to create its own voltage reference for other DER to latch onto and effectively able to sort of stabilise and grow that power island. So anchor generator, so keep an eye out for that term. Another term is the distributed restart zone. So that's effectively a zone which forms a stable power island. So on that diagram on the right hand side, we've got a number of different DER resources, so wind, solar and anchor generator. There'll be demand as well. So effectively balancing the demand and generation in a stable sort of power island. So that's what we call our distributed restart zone. So distributed restart has been running for 2 years, and we've got another year to go. So this slide just shows you what we're going to deliver in the final phase of the project, the demonstrate phase of the project. So essentially we're going to take those designs that I referred to and we're going to demonstrate that they work. So the organisational model that we've designed, so we're going to road test that through desktop exercises in the spring. So that's going to involve stakeholders, and we're going to effectively do a series of desktop exercises to make sure that organisational model will work together, and any sort of feedback from stakeholders of how we can tweak it and improve it, we'll incorporate those into sort of future exercises. So the next part is around the automation. So we've proved that automation is key to allow this Black Start from DR service to work. We've currently designed, got a set of designs around what the automation might look like. The next phase is to build a prototype of a control system which will do this, which we intend to get back around about the back end of the summer next year. And then the intention is to test that prototype through hardware in the loop testing to prove that it works. The next phase around live trials. So we began our live trials at the end of October through the Galloway case study in Scotland. We're going to do some detailed case study live trial work heading into 2021. And all the learnings from those live trials will build on each other, and we will communicate those learnings out as well as we go through. The sort of fourth element is around the commercial procurement design. The next phase of that is to refine our designs involving sort of stakeholder feedback. What we want to do is a dummy procurement event in the summer to prove that that commercial framework will work. And the last element is the end-to-end telecom. So proving that our designs for resilient cybersecure telecoms will actually work in the real world. So that will be the piece of work around that for next year. So the results from our network case studies show that it is possible, it can work. Black Start from DER restoration can work. So those studies, we've considered a number of different options for restoration, all the way from option 1, which is establishing a small, stable power island involving an anchor generator and a small bit of demand, all the way through to energizing and growing that power island through to the next grid supply point and utilizing the resources at that grid supply point, and extending further up to the higher transmission voltage levels at 275 and 400 kV. So it is possible. It is true to say there are technical challenges, particularly around system protection and system strength, that we need to overcome when we are designing an end-to-end restoration service. But our network case study results show that it is possible. And there'll be more details on that coming out in our next Power Engineering Trials report in December. So currently, the electricity system operator is very much the lead for Black Start restoration. So the ESO will procure Black Start contracts with big power stations to provide Black Start capability. The ESO will instruct those Black Start generators during a restoration phase, and the ESO will coordinate how that restoration goes nationally. So from a Black Start from DER perspective, so as a project we've done a lot of work on organisational models, how we organise ourselves on the day, who will instruct the Black Start restoration process, who will coordinate, how it all stitches together, who's responsible for what. And during our options phase, in the first part of the project, we created 4 organisational models. The first 2 models were with the ESO leading that Black Start restoration phase, and we worked up a fully manual version of that process, which is effectively what the current processes are, and a fully automated approach to that process. And on the flip side, we worked up 2 models with the DNO leading the Black Start restoration. One, a fully manual version of that, and a fully automated approach to that. So those 4 organisational models we took on the road and got our sort of stakeholders to work through those models, and we got some feedback from from our stakeholders on that. And in particular, the ENA Open Networks have been really good on this. And we've come up with a central model, what we call our central organisational model, which is our organisational model we're going to go forwards with in our sort of next phase. And this very much leaves the ESO in overall coordination at a regional and a national level, but it gives the DNOs, creates responsibility for the DNOs to coordinate restoration at a local level. So what I mean by that is that the DNOs would be instructing the black start services from the DERs within their license areas. So that's a new role for the DNOs our central model creates. So another element to this is around the kind of workload and the time it takes to restore networks and things like that. So we took our 4 organizational models and we did some sort of risk assessments with those models. We looked at all different elements of sort of managing the workload, the numbers of resources we need to do restoration, the coordination of those resources, both at a company level and an industry level, the IT that's needed, the communication networks needed to make all that work, and then we scored all those different elements, and ultimately this leads to our central organizational model. So there's a big part of this is around automation. So in order to grow a small power island, utilizing the DER and applying the demand, growing the island into a sort of stable island, and then expanding outwards. And to do that in a smooth, transitional, stable way, utilizing the resources we've currently got, not adding necessarily additional people into the equation. Automation is needed, absolutely essential to make this work. So we've created this concept of a DRZ controller, DRZC, which is effectively a control system which will do this for us. So our project will deliver the design and a prototype, and effectively testing that prototype for such a DRZ controller that we can roll out across the GB networks. So automation is a big part of this model. Telecommunications is another element to this. So this diagram sort of shows some of the interactions between the different stakeholders, between the ESO and the DNO and the DR control points and things like that. So an end-to-end resilient telecommunications system, so that all parties within that loop can talk to each other on the day, is absolutely essential. So, and that's what one of our designs refer to when we're talking about functional telecommunication requirements. So the organizational model, the central model, stitches all this together. The need for coordination across all the different stakeholders, the need for automation, and the need for resilient telecommunications. So our commercial designs have considered all the different technical elements of an end-to-end black start restoration service. All the things like being an anchor generator, the sort of technical requirements to be an anchor generator, the ability to self-start and provide a voltage reference, and all the other services like ability to fast balance, so offer up fast energy to fast balance, the ability to control volts through reactive power provision, the ability to provide stability services, inertia services, and fault and feed type services, and obviously the demand side as well. So all those sort of technical elements of an end-to-end black start service we've looked at, and we've come up with 3 approaches of how this might work commercially. First approach 1 on the left, looks at a single lead party or contracting entity that will be responsible for delivering all of those sort of technical requirements as part of a sort of black start service. So that aligns to the sort of current black start procurement process. On the right hand side is approach 3. This looks at splitting out the anchor generator specifically and procuring for the anchor generator, and having the other services maybe sort of mandated through industry codes. And the middle approach 2, now this is looking at splitting up all the different elements of an end-to-end black start restoration service, from the anchor generator, which will be a separate element to procure for, and all the other different elements as well could potentially be bought separately or in combination. So we thought approach 2 offers the best solution to break down barriers, open up marketplaces for providers to provide their different services in the sort of restoration space. So we've been working with our stakeholders and refining our approach on refining our design for approach 2, and this is very much the approach we're going to go forward with. The other side of this is around procurement. So the approach 2 gives us a way that we can procure differently as well. So for example, the anchor generator, we might procure through maybe a longer term contract, potentially through a tender or something like that. And then the other services that we call in top-up services, you could procure over a short time frame, maybe sort of week ahead, day ahead, or even within day, through e-auctions or sort of other sort of short-term platforms. So there's an analogy here with the sort of Pathfinder products that ESO is providing. So this fits well within the sort of Pathfinder approach as well. So approach 2, so keep an eye out for our sort of stakeholder engagement pieces. Approach 2 is very much what we'll be going forward with on a commercial design procurement methodology. So to summarize what to look out for the next few months of Distributed Restart. So our live trials that started at the end of October will continue right throughout 2021. So we're finalizing our designs for those live trials. One of those will be involving a biomass generator. Another one will be involving a hydro generator, and a third will be involving a grid forming battery, which is quite exciting. We've also got some reports coming out in the next few days detailing our functional specs for resilient and cyber secure telecoms and for DAR participants, and a functional specification for our restoration zone controller. So keep an eye out for those reports. They will appear on the Distributed Restart webpage. So by all means, have a look at those. We've got the desktop exercises to road test the organizational central model. So they'll be happening in the spring 2021 and rolling into the summer period. We've also got the restoration zone controller. The prototype will be available late summer, and then we can test that prototype with hardware in the loop testing that we intend to do in the autumn period. So we'll be reporting on that. And there'll be a trial procurement event in summer next year. Thank you all for listening. Please stay in touch and take care.
Hello and welcome to our flexibility panelists today. It's been a pleasure to introduce the previous projects. Today we're talking about flexibility, of course, and it's one of the most important themes when discussing the energy transition. So it's not just about the new energy sources, but the consequences and the fallout from switching to a new energy mix. Today I have the honor of having with me two great representatives of the energy transition today. Unfortunately, Audrey Gallagher, who is Director of Policy and the Deputy Chief Executive of Energy UK, won't be joining us as she's not feeling very well. But I still have the pleasure to introduce to you Sotiris Georgopoulos. Sotiris has over 10 years experience in UK power networks, and within which he's held a number of positions in a wide range of areas, such as innovation, construction, and energy services development. Today, Sotiris is the head of UKPN's smart grid development, and as such is responsible for the design and delivery of UKPN's flexibility markets, smart grids, and distribution system operation capabilities and programs. So welcome, Sotiris. It's also an honor to introduce Keith Bell, which I'm sure you're all familiar with, who is the Scottish Power Chair in Smart Grids. Professor Keith joined Strathclyde in 2005. Today he holds the university's Scottish Power Chair in Smart Grids. He has previously worked as an electrical engineer, research in Bath, in Manchester, and in Napoli, and as a system development engineer in the electricity supply industry in Britain. He's also co-director in the multidisciplinary UK Energy Research Centre and an invited expert by SIGRE, Study Committee on System Development and Economics. Professor Keith is a member of UK's Committee on Climate Change and a chartered engineer, as well as a fellow of the Royal Society of Edinburgh. Throughout the years, he's been a trusted advisor to governments on electrical engineering and power systems, the Scottish Government, UK Government, as well as the Republic of Ireland Government, as well as the Northern Ireland Executive and Ofgem. So we've got some great panelists today, and it will be a pleasure to discuss flexibility with both of them. So welcome, Keith and Sotiris. So you've heard our presentations and you listened to the progress that has been made on some of these projects. Some are presenting for the first time at the conference. Others are just giving an update, but quite an update. So I'd like to open this conversation with Professor Keith and understand from you, what are the questions that we're trying to address? What do you think are the big issues that we're trying to solve in the flexibility space?
Yeah, thanks very much, and thanks for the introduction. Well, I mean, since liberalisation of electricity industries around the world, we've had markets for trading of electrical energy and competition in that, and you know, we could point towards a great number of benefits from that. But an electricity system has very narrow physical margins for error in terms of its operation, and it's critical to get the operation right. Again, we can see from incidents around the world what happens when things go wrong, you know, go very badly wrong. So to what extent can stable operation be left to energy markets, or do we need something else? And from the beginning of liberalisation, we've had ancillary services and redispatch markets, such as the balancing mechanism that we have in Britain. And at the beginning, most ancillary services were what you might call administered. But in recent years, there's been an attempt to introduce competition also into them. Nowadays, we might call ancillary services and redispatch markets flexibility markets, dealing with those things that need to be done in real time, which the regular energy markets don't do. So what's different now from in the past? I mean, a lot of power coming from low carbon renewable sources. And in terms of, you know, physical electrical entities, it's really important, very significant that these are generally asynchronous. And we also have the potential to access services from distributed resources, meaning generation or storage or indeed flexible demand connected within the distribution networks. And that's really important because there's a lot of it potentially available, but it's a lot of smaller individual actors. And what are the best means of accessing them? So this is where I think some of the kind of challenges lie now, the changing physical nature of the system and the opportunity presented by distributed resources.
Thank you. I love how you're calling it the opportunity rather than a challenge. This is actually my mistake. In innovation, we always try to see things as an opportunity. So change is actually a good thing, not necessarily an issue. But it's a very interesting point that you're raising, and I'd like to bring Sotiris into the conversation. So Professor spoke about services coming from different locations, so from the distribution network. I'd like to get your take on this as UKPN's market reference person, and what is it that you guys are prioritizing right now in this space? And what do you see as your challenge or as your opportunity, as we call it?
Yeah, absolutely. Thank you, Carolina. So what we are seeing, so the way I think Keith laid out really clearly the fundamentals and the evolution, and one of the areas that we have seen great growth over the last certainly 2-3 years in the UK is DSO ancillary services. So flexibility to support distribution network needs, primarily to to provide capacity under planned or unplanned unplanned or unplanned conditions. But certainly we have seen a great growth in terms of bringing in competition to distribution network needs. And looking at alternative ways of providing capacity. Traditionally, distribution companies, we are infrastructure companies. We have been building assets where we need additional capacity. But what the distribution companies in the UK have been leading on over the last 2-3 years is flexibility tenders and other forms of flexibility procurement to really bring that flexibility into the market. According to ENA's latest flexibility stats that are on the ENA website and were published in sort of mid-November, we this year the DNOs collectively tendered about 2 gigawatts of flexibility products, and essentially are looking at aggregators, flex providers, distributed energy providers to provide that. So that really has been the top priority: introduction of competition to network needs and getting flexibility and on-build solutions on level playing field with asset solutions.
That's very interesting, Sotiris. Now, you're talking about bringing competition, and this is one of the big challenges that we have, as competition is not just about getting many players in the game, but it's also about understanding what services can be provided and how they may cannibalize other services as well on the grid. Now, a lot of this is being discussed and being faced by both ESO as well as the various network companies, which introduces one of the other big pillars of the flexibility conversation, which is coordination amongst us and how we work together to enable these markets, to enable that competition while minimizing the overall risk to the system. Would you like to pick that up?
Yes, absolutely. So, in distribution companies procuring flexibility and essentially using flexibility and activating flexibility for their own needs, you now have emerging conflicts between those, those flexibility, if you like, products and activations, and the national system operators, the ESOs, as you mentioned. So coordination between transmission and distribution is something that has been talked about, for a while. We have been focusing on learning by doing. I think the projects that we've just seen, Fusion is a framework around managing coordination, and certainly Power Potential has trialed successfully a coordination framework focused on reactive power, but looking at how the national operator and the DNO can work through end-to-end a reactive power service and do it in a way that gives the whole system benefit rather than triggering the conflict. It's not coordination, it's a system issue. You can do the engineering of the systems, but it's also an issue around roles and responsibilities, and can become tricky to solve. So in Open Networks next year, we'll take stock of all the learning by doing that we've done through national grids, pathfinders or regional development programs, some of the innovation work that has been done, and we'll bring it together to see whether we can address some of the issues, certainly around conflict resolution, and look at things like primacy rules. Should we be using primacy rules? Where market-based coordination can work, and what's the role of third-party platforms, and bring this together to try to, if you like, agree some principles that can then start being applied across the UK power system.
Now, talking about flexibility markets at a DNO level or a transmission level opens up the question around geography and how that can be addressed. And this, at the same time, reminds me kind of your bio, Professor, and the fact that you've advised, Scottish government as well as the UK government, Northern Ireland executive, and so on and so forth. Be good to have sort of like an idea of the different challenges that we're facing geographically and how we may face them separately, and what kind of approach should we have when designing markets.
Yeah, well, clearly, the geographies determine the different sorts of resources that are available and the different characteristics of demand, heating need and that sort of thing. But there are different electrical characteristics as well that come out of that for the system. I think Sotiris makes a really important point about coordination. So that coordination has to be right for the system as a whole, because although, in GB, we have these very different regions, we have different distribution networks, it is all electrically interconnected. Finally, it is one electricity system. And you think about the coupling to need for heat and transport, actually, you could think more widely about one energy system. So it's a big challenge to get it all coordinated in an optimal way, meaning that we kind of can reduce emissions while still meeting demand for energy reliably at least cost. And that's what we're trying to achieve. And the coordination, I think, as well, has to happen not just across the different locations, but across different timeframes. So it goes right from investment timescales through to operation. So flexibility markets, in a sense, could be thought of as dealing with the variability and uncertainty in real time. Those things that the energy markets, the forward markets, have not been able to resolve correctly because of the variability and uncertainty. But they can only work if the physical capability is there in the first place. So there's often like two components to a flexibility service. One is the capability there? Is it available at a particular time? Does it have a certain kind of, range of output or input from a particular device, for example? And then secondly, are you going to use it? So what are you paying for it to be available? And then given the uncertainty, and part of what you're doing is being ready for bad things that might randomly happen, how do you utilize it, and then do you pay for the utilization? But the availability is both, is there an opportunity cost in making something available on the day? But there might be an investment cost in terms of enhanced capability, perhaps, or some capability that is inherent to some equipment. So actually there's a need for coordination then with standards and kind of things like grid code and engineering recommendations, and a kind of another component of that, which I think is a really big challenge for the distributed resources and accessing them. It's the monitoring, the observability and the controllability, which points towards communications and data. I think you mentioned data earlier on. How can we get the kind of comprehensive enough observability and controllability that allows us to access the potential service contributions and then to be sure that they are being delivered in the right way? What's the least cost way of getting that sort of capability, and who should pay for it?
So that's very interesting, an introduction of data. And of course, this is one of the big themes that all the network companies, the industry overall, and not just our own, are focusing on today. Data is a great enabler of innovation, of future changes, and so on. Now, Professor, in Strathclyde and across the academic world, you are at the forefront of research and you're looking at this. I also referenced earlier, it feels like we're building a ship at sea because not much is known as to what we can expect from a fully renewable or almost fully renewable power system. So what are the consequences? What is the fallout? Question to you is, what else should we be looking at? So we've seen some of the projects. Today, we're looking at markets. We're looking at bringing those markets in real time. We're looking at who should be providing those services. We're looking at new services coming from new people, geographically located services, and trying to minimize the impact on working as usual. So we usually say that, when we're trying to facilitate the energy transition, it's not just a question of running a system at zero carbon. There's always a piece missing there, which is guaranteeing the same level of service we have today. Because we could do system regulation the Johannesburg way and have, blackout for 4 hours every day, and that would be quite cheap to manage, but that's not what the British consumer is expecting from us. Now, what is the next step? What else should we be doing? What are we missing here?
In a way, the next step is the first step, and I think always was the first step. I think, as I mentioned at the beginning, an electricity system is heavily constrained by its physical characteristics. As I mentioned before, if it goes wrong, it can go wrong very quickly and in a very big way, and it is hugely disruptive to society because so much depends on electrical energy. And that's why we've got these kind of peculiar arrangements such as ancillary services and balancing mechanism and these new kinds of flexibility markets in the first place. So the fundamentals are, well, what is the system like electrically, actually, in this future world, when we've got a lot of asynchronous resources, not just at transmission level, but a lot of it at distribution level? we have to get back to the beginning and think, well, how is this going to work? You know, when we've got, for example, in an extreme, no synchronous plant on the system, can we operate the system successfully? And I think we've kind of, my feeling is that even at a kind of policy level, it's sort of been forgotten about, that is still a major challenge. We've almost kind of been blinded by the fantastic success that we've had over the last 15 years in Britain in reducing emissions associated with electricity. You know, it's kind of, you know, a fraction, half of what it was before, or even less. Well, that's substantially less, actually. Half of energy, coming from renewables. The assumption is that, oh, that's done and dusted. Actually, it isn't. You know, the kind of the next kind of phase of getting from 50% from renewable sources to, in particular ours, 100%, when we haven't got, as other countries do, lots of great hydro resources, is still a major engineering challenge. And then from there, the flexibility markets have to be designed such that they meet the engineering challenge at least cost to deliver the quality of service that you mentioned.
And so curious, what are your next priorities then? So given the context that Professor Keith has presented, what do you think the next step from a DNO, DSO point of view are, and how do you see your maturity into this space evolving?
Yeah, and I think when you look at some of the innovation projects we just covered, you know, when you look at power potential, the southeast region, and you know, Carolina, your colleagues remind us that you know, very frequently, you know, the southeast region does run significant amount of time without any major synchronous generation on the system, and you know, there's a lot of renewables. There's interconnection. You know, the prime reason, as Biliana has explained, behind power potential is dynamic voltage support, and obviously, you know, there are asset solutions to that, but there are also flexibility solutions that we've looked at. So I think, and you guys have talked about data and the importance of digitalization and kind of the benefits that can deliver. Now, I think we have the right ingredients. For me, the key will be to accelerate the adoption of that innovation. So we need things like the projects we cover. We need things like power potential. We need things like distributed restart. And to respond to the engineering challenge, we need to get them in production at scale faster, basically. So for me, Carolina, I think that's really from a DNO's perspective and DSO's perspective, that's really our challenge. Our challenge is to look at what we are doing and essentially do it at scale, more of it, and faster, in good time, to essentially deliver best value for customers. Because at the end of the day, that's why we're doing it, right? It's best value for customers. So looking on the distribution networks, for us, electrification of transport is probably, and now partial electrification of heat are going to be the major challenges of the next decade in our world, right? But at the same time, you have doubling of offshore wind capacity. You have all these other issues that Keith mentioned. So I think the priority is to get the capabilities, to get the skills, to get the right people, generate pace, and get scaling up these capabilities to be able to deliver the benefits.
I was going to say, I totally agree with that, Satiris. Yeah, I mean, there's a need for skills. We're going to be, maybe doubling electrical energy demand in the next kind of couple of decades in terms of, at the same time as reducing the emissions intensity down to zero. So there's a lot of work that needs done at all levels, really. Kind of fitters, technicians, engineers, project managers. For me, as an academic, I've got a responsibility to help to educate some of these people, and again, it's at the different levels. So it's not just your kind of bachelor's and master's graduates. It's also people with a PhD who've kind of be able to think about and try and address some of these major challenges. So I would strongly encourage the sector to come together to actually invest in this sort of educational capacity. Unfortunately, the research councils cut the money that was going to the two centres for doctoral training on future electricity systems. They don't exist anymore. And it's a really bad time to have done that, I think, given the sort of challenges that you're outlining. So I'd encourage everybody who's involved in the industry to get onto their chief executives to start investing in some of this future talent.
So that's all the time we have today. And with this call to arms from Professor Keith Bell, we'll have to close. Thank you very much for your participation. I think this is a topic that warrants a lot more space, but we're going to have many more opportunities in the future to keep the conversation going. So thank you very much for coming in today, and we'll speak soon. And to everyone else in the conference, enjoy the rest of your videos and conference today.